I were to define chemistry, which is a noun and in Filipino it's known as Kapnayan, it is a branch of science that deals with the different transformations that matter undergoes, along with the changes in properties and the transfer of energy that accompany it. Let's break down my definition into the words that are in it. First of all, science. When we say science, this is a logical, evidence-based approach in solving problems and answering questions. Through science, we generate new knowledge and concepts through observations in experiments. When we do science or when we undertake scientific endeavors, we rely solely on the results of experiments in our decision making and in generating new knowledge. We do not rely on fiction, on prophecies, rumors, hearsay, and other non-tangible opinion-based matters related to what we are studying. Next up, matter. When we say matter, it's anything that is tangible by having mass or weight and occupies space. When we say that something occupies space, it has volume, alright? So when we say matter, these are all the things that are around us. All the things that we can touch, we can feel, that is tangible, alright? That includes the gases that we breathe in, like oxygen gas, and the gases that we breathe out, carbon dioxide, those dumbbells, water, the clouds, that fluffy stuffed animal, the pencils that we use, and so on. Other examples of matter include, laptops, oxygen, water, and fire. What's not counted as matter are, abstract concepts such as peace, beauty, love, and the very subject matter of chemistry is not matter. But it does matter. Next up, transformations of matter. When we talk about transformations of matter, we are referring to what we call chemical reactions. Chemical reactions are processes where new substances or chemicals are formed from one or more so-called ingredients. These are examples of chemical reactions. For instance, we have the burning of wood, the digestion of food that we eat, fermentation, when we turn sugar into alcohol that becomes our wine and beer, photosynthesis, the process in which plants use carbon dioxide, sunlight, and water to become their own food. These are not examples of chemical reactions. On the other hand, chopping wood, molding clay. These are what we call physical changes. They do not alter the chemical composition of the materials that are involved in these processes. Next up, the transfer of energy that accompany the chemical reactions. Chemical reactions are accompanied by transfer of energy. Some reactions require an input of energy, and we call those endothermic reactions, such as the cooking of food. Through cooking of food, we introduce heat as a means of breaking down the proteins and other biomolecules, therefore making them edible for humans. While some reactions release energy, such as the combustion or burning of fuel, and in these processes, energy is released so that this energy can be used for our cars and other types of vehicles. So that is my definition of chemistry, the branch of science that deals with matter and its transformations. Professionals who specialize in chemistry are what we call chemists. Now, what do chemists do? Well, they can do many different things, such as the design and synthesis of chemicals, quality control. For example, when companies make soaps or food products, chemists are the one who are in charge of checking if these products are effective and useful when they reach the consumers. Chemists also dabble in environmental monitoring to help us make sure that our environment is safe and sustainable. And of course, in the research and development of new materials and chemicals, such as graphene in this case. Graphene is known as the toughest material made by man. And of course, chemists are the ones who developed this material. One of the first concepts that you'd have to learn in chemistry is that all things in the universe are made up of atoms, such as these ones. You can think of atoms as very small spheres or ball-like particles that comprise all of the materials in the universe. This sphere labeled H is called hydrogen. This sphere labeled O is oxygen. This sphere labeled C is carbon. Fe is iron. Si is silicon. And Cu is copper. These are different kinds of atoms that make up all materials in the universe, and you can find a list of them in what we call the periodic table of elements. As of today, there are 118 known elements in the universe. Substances or materials that are made up of one kind of atom are what we call elemental substances. Examples of these are the metals used in spacecraft, which is made of titanium, the tip of pencils, which is made of carbon, hydrogen gas, which is used in aviation back then. In this particular case, hydrogen gas was used to inflate the aircraft Hindenburg, which ended up in a very nasty disaster. Fe, or iron, is also an elemental substance. Copper, which is used in coins and denominations, is also an elemental substance. And oxygen gas is also called an elemental substance. All of these substances are made up only of one kind of atom. Meanwhile, there are also substances that are made up of two or more atoms, and we call them compound substances. Compound substances are made up of two or more kinds of atoms that combine chemically. For instance, we have water, and particles of water are made by combining two atoms of hydrogen and one atom of oxygen together. Carbon dioxide, the air we breathe out and the byproduct of burning, is made up of two atoms of oxygen and one atom of carbon. Rust, on the other hand, Fe2O3, is made up of two atoms of iron and three atoms of oxygen. Elemental substances and compound substances are what we call pure substances. These substances can stand alone on their own, and they have their own distinct properties. Of course, we have the freedom to combine physically two or more pure substances to form what we call mixtures. Examples of these are salt water, which is salt in water. We know that salt is sodium and chlorine, dissolved in water, which is H2O. Steel, which is a solution of iron and chromium. And soda, which is a solution of water, sugar, carbon dioxide, and other stuff. Pure substances and mixtures form the entire domain of matter, which we are concerned with in the study of chemistry. It's also important to learn about the different states or phases of matter that we can encounter in the universe. We have solids, liquids, and gases. Now, you probably have learned this back then in your early years. Let's just go over them one by one. Solids have definite shape, and the particles of solids are close to each other. Liquids, on the other hand, are fluid, and they follow the shape of the container that they are in. The particles of liquids are far apart from each other as opposed to solids. Gases, on the other hand, are also fluid. They also follow the shape of their container. But compared to liquids, the distance of the particles in gases are very far apart from each other. Now, where does chemistry fit in the grand scheme of things? Well, as most scientists say, in order to study chemistry, we must learn a little bit of physics, especially if you will be learning the deeper aspects of chemistry later on in life. However, in our study of chemistry now, we won't be needing a lot of physics. And in order to understand biology, you'd have to learn chemistry because, the proteins, the carbohydrates, the nucleic acids, and the lipids that comprise biological organisms, all living things, they are chemicals too. And in order to master or learn about, organisms, you'd have to learn about the different chemicals that comprise them. The link among these three major branches of science is mathematics. And of course, we see that chemistry is also used in other disciplines such as food technology, metallurgy, geology, engineering, art, and medicine. Being in the middle of all these disciplines, chemistry is known to be the central science.